In this video, we'll go over unit testing in Flutter. Hey guys, and welcome back to episode 4 of the Stacked Architecture series. This video will go over an intro to unit testing to prepare us for 100% coverage of our business logic through unit testing the view models and the services. This video will be broken into two parts: the basics of unit testing and then services and mocks for production unit testing. So let's start with the basics of unit testing. Unit testing is a form of testing where you write code to test the smallest testable parts of your software. It has some inputs and usually one output or result. If you've ever seen the testing pyramid, this is at the complete bottom, which means it has the largest coverage and the highest volume of tests given the functionalities of your software and your definition of a unit. Similar to other popular techniques to help you produce better software, there's a lot of arguments around what a unit of software is and what a unit test should be. This tutorial is my interpretation that I've used to describe my units over the years. So what exactly can be defined as a unit of work? Similar to the single responsibility principle, there's a lot of different opinions on this section, and it puts it into the category where it's a mix of personal opinion and situational awareness. The situation in this matter is your code base and its intention. There's a lot of people that consider a function to be a unit, a lot of people that consider a class to be a unit, there's people that consider an entire feature to be a unit, and the list goes on. Some people go very atomic and others go very broad to cover the entire code base. I think mine falls in the middle, and I'll give you guys a list of things that I use to define unit tests for a specific function or a property. It's just a list that I can go through and then create unit tests based on the title and the description of this rule, if you can call it that. So the way to use this is to look at the function you want to test and then go through this list of rules and then create tests based on those things. The first one is testing an assumption. There are multiple things that we assume when calling a function or a property. This can be a check to confirm that something is not null. You can check if a certain value is set when you get to a certain point. Or you can check something like the order of function calls to make sure that the correct function was called before you called the actual function. The second rule is testing a state. This is where we'll check if we have called this function, what is the state of the object being tested. You call the function and then you confirm that it's the exact state that you want it to be in. This applies to multiple actions as well as a single function call. The next rule is testing an interaction. And this is not an interaction in terms of a user interaction. This is an interaction between a view model and a service. This is where you'll check if I call this function on my view model, will it call this function on a different service? This seems a bit silly, but it's an important place in documenting the interaction between services and view models. The next rule is testing conditionals. This is when your function might have multiple exit paths. Tests in this rule will look as follows. When calling this function, check if the service X was called, else service B was called with this value. The next rule is testing your error handling. So given this function is called, it should throw an exception with this specific message. You can check for exception types, and it also covers checking what happens when your code does throw an exception. And then the last rule is testing how your code reacts to values from services. This is where the mocks come in, where you can tell the mock to return values, the wrong values, exceptions, null values, or not return anything at all. You'll test things like results being returned from the API. You'll test what happens if there's an infinite loop. You'll test all of those things that might occur during your unit of work. Now, if you read and understand this clearly, you'll see that all of these rules actually overlap with each other. This is not a hard set of rules. It's more like bullet points to help you create unit tests and define what you can actually test in a function. You shouldn't be writing any tests that serve no purpose. This set of rules is there as a guideline to ensure that if you don't understand exactly what a unit of work is, you can use these rules and look at your functions and properties and then start writing tests that will help you determine if there's a bug in the future or not. The next thing we have to talk about is, what do we actually test? So what we'll test in our code bases is the view models and the services. That is what we will unit test. If a service is wrapping another library, We will assume 100% test coverage on their side and we won't test their library's functionality. We can still test our assumptions of the library, but we won't do a deep test of the actual functionality. Therefore, the services that's wrapping third-party libraries will usually always be mocked out in the unit tests. We will also test our view models, and a view model should always be testable. It should always be unit testable. That's the reason why there should never be any UI code in a view model. No controllers of any kind, definitely no widgets, and never have the build context in your view model. This will make it very hard to test because you'll have to actually start up Flutter, which means you have to start up an emulator just to run a unit test. Unit test should be quick to run and should be run rapidly and continuously as you are developing on that specific function. Now that we have all of those definitions out of the way, let's get a little bit more closer to the code by defining the structure of a unit test as it will appear in our code base. So unit test serves a dual purpose. Firstly, it documents your expectations and your functionality of your code. And secondly, it allows for easier regression testing when changing your code down the line. When all your unit tests pass, it means that everything you wrote up until that point, plus all the assumptions that you made, is still 100% true. This would be for the order of function calls, if values are null or not, what value it is at a certain point, when a certain function is called, how many times a certain function is called. All of these things have to be tested because if it's been changed by another developer, you can confirm that the bug is not in your code and it's from the new code that's been produced. So with that said, the biggest thing we have to make sure of is that the names of our unit tests actually make sense and that the other developers can read it as documentation. Since it serves as a form of documentation, the naming should have a strict naming convention and it should always be followed. The naming convention that I've been following since my start in unit testing is as follows. There are 4 basic things that I require for a unit test to have a proper name. The first thing is that we need to know what class is being tested. You can use the file name if you're a functional programmer. The second thing is we need to know what function is being called or which property is being inspected. The third one is we need to know how the function was called and with which values if appropriate or with which assumptions if there are any. And the last point is that we need to know what to expect as a result. When running a unit test, you should see it read as the following one in the IDE. Product details ViewModel tests. We are testing the update product function. When called an update card product is successful, should call back on navigation service and pass the result. That is how one test should read, so that when your developers or you read it again, you understand exactly what it should do, where it's being used, what function is called, and what you are expecting. You should go over to FilledStacks.com and look at the unit test part 1 tutorial, since there's a lot more in the written tutorial than in this video. The next thing to look at is the unit test structure. When writing a unit test, there is a certain pattern that is followed. It is the AAA pattern, which is arrange, act, and assert. But to put it in normal English, you can use setup, action, and result. So in the arrange or setup section is where you set up the code that you'll be testing. You'll do any configuration and create your mocks and pass it the values that you'd want it to return. When you act or execute the action is where you call the actual function that you are testing, and in the result section you will check the values and see if it is the correct values that you expect it to be. That's basically all the setup and the explanation. I think you'll have to watch it a few times to get it stuck in your head. You can also just practice along afterwards, where I will give you some tests to write and you can practice the arrange, act, assert as well as the naming of your functions. Let's write some actual unit tests so you can see how my code is set up and the file placement and naming. You can download the starting code from the written tutorial under the thumbnail. There is a download code button, or you can download it from the link under writing unit tests. You can go ahead and remove all of the code under the test folder. Then we'll create a new folder called ViewModel_tests, and we'll create another folder called service_tests. Then in the test folder, we'll create one last folder called setup. Within the setup folder, we'll create a new file called test_helpers. This file will contain the setup function to remove any duplicate code from your tests, as well as make your tests more readable by putting all of the setup helpers into one function call. Then we'll create another file called test_data. This is where we will keep all of the results that we expect to be returned from mocks and anything else. Then under the ViewModel tests folder, create a new file called validation example ViewModel_test. Your file has to end in _test ... for the Flutter plugin to pick it up as a unit test in the IDE. Files that end in _test will be run when you enter the Flutter test command in the terminal. To make the unit testing process a bit faster, I've created snippets that I use in my personal projects to create my tests. Head over to FilledStacks.com and go to the unit testing article, press Ctrl F and then type snippet, and then go to that file and add those to your snippets in your Visual Studio Code IDE. We'll start off by creating the main test group by typing test M and pressing tab. This will create the group with the proper name for the file. Then we'll create the test suite for the can submit property. Type test G and press tab and type in can submit. For the test itself, we'll start off with checking if can submit is false after the model has been constructed. The rule we are using for this is testing an assumption. For the title of the unit test, we'll type when constructed can submit should be false. And then the first line of the unit test, we'll construct our validation example ViewModel and put it into a variable called model. And for our assert, we will check the expect function and call the can submit property and then pass in false as the expected result. Now above all the tests and the test suites, which are groups, you'll see the run and debug code lens link. When you click that, your test will show up on the left side where it will be ticked as green when it passes or as red when it fails. You can also run Flutter test as I did in the terminal and you'll see if your unit test has passed or not. For the second test, we'll use the rule testing a state. We'll call the setName function and it should still be false because there's no contact set on the ViewModel. So for the test name itself, it'll be when setName is called and no contact is set, should be false. We'll construct the ViewModel and then we'll call setName on the model. Then we'll call the expect function and we'll pass in can submit and check if it's false. If you press the run button above the test, you should see that that passes as well. We'll do one more test. Type test S and press tab, and then you can type in when setName is called and valid email is set should be true. And then we'll do the same thing. We will instantiate a new instance of the validation example ViewModel. We'll copy paste the code from the test above. We will set the name to FilledStacks. We'll duplicate that line of code and then we'll call set email instead and pass a valid email dane@filledstacks.com. And now we expect can submit to be true. That is basically the process that I follow when writing unit tests. Usually I don't write my unit tests after I've written the functionality because that makes it a little bit more difficult. This also makes it so that you might be writing your unit tests in a way that hides the bugs that is already there. What I do is I follow a simple TDD approach, which is not as strict as it used to be for myself a few years back, where I still write some code without writing tests, but there's always a failing test when I'm writing code. This is how I found for myself to be more confident in the code that I write. It also makes me feel more secure about bugs, specifically in the business logic. If you go to the written tutorial, I have given some unit tests that I think would be important in this actual function. If you want to practice your unit testing functionality and your skills, go to the written tutorial and then write tests for the names that I have put down in that list. Once you have written all those tests, there is no line of code that you can change without one of those tests failing. This is what you would consider to be 100% test coverage for your business logic. That is what I usually aim for my services as well as my view models. And we also have a solution in store to do that for our integration testing as well. With that said, I'm not going to go through all of those unit tests for you since it's a very boring duplicate process to watch. One thing I'd like to show you is setting up your launch.json file to run your unit test when you press F5. If you open up the debug tab on the left, the third icon from the top, you will have one of your configurations which will be set to launch your Flutter dot file. We'll change the name of this configuration to run all tests, and then we'll add a new property called program, which will be ./test/. Now in the top of your debug window where you see the run and the drop down, you can select run all tests and it will run your code in the IDE whenever you press F5. You can also add back the normal Flutter configuration so that you can still run your code through F5. Next week we'll go over unit testing services and mocking with Mockito. If you have any questions, please leave it in the comments below. And if there's something specific you want me to cover in unit testing, please let me know as well. This is all for this week, and I'll see you guys next week. Bye bye.